Hello! Today we're going to show you how a fluid calibration works with Cal.flow and EasyCal. You will need a fluid test bench that allows the master and the test flow meter to be run in series, and it also has a manually adjustable flow rate. You will need a Windows PC with EasyCal installed and the Cal.flow case. The Cal.flow calibration system is used in conjunction with the EasyCal software to perform flow meter calibrations with high precision. The process is guided through the PC software and results in a PDF calibration protocol with all measured values. You can calibrate a master and a test flow meter using the reference principle and apply up to 24 master calibration points. With the Cal.flow case, you will get the Cal.flow itself, 2 M12 cables, 2 T connectors, 1 USB-C cable, and an external power supply with 24 volts, and also a license certificate which allows you to download EasyCal. Connect the Cal.flow to the PC using the included USB-C cable, and then connect the master with the included M12 cables and also the test flow meter. You can use the T connectors also if you have existing cabling with 24 volt power supply where you want to pass your signals to. If you get the power supply from the bench, you can omit the power supply that is included with Cal.flow. After opening EasyCal for the first time, you may enter your serial number of the Cal.flow, which is written on the license certificate, and you can start with the specification of the flow meters and the measurement parameters. If at some point you don't know what to do, you can always refer to the online manual, which is included in EasyCal. You can find it using the help button at the top. In the first step, you will set the master calibration data, including the type, the serial number, the interpolation factor, the channel type, and also add the calibration table. The most easy way to enter calibration data is to use Excel, where your existing calibration data is, copy all the cells and paste them into this linearization table. You will only need to paste 2 columns, as the third one will be calculated automatically. For example, in our example, we pasted the frequency and the K-factor. As you will notice in all further steps, is that every step is modular and has a preset functionality. This allows you to save the configurations you made in this step and also reload them later. In step 2, you will set the power supply for the flow meters. There are 3 different options. Option 1 is using the external DC jack supply when there is no supply on the bench. Option 2 is using the existing bench power supply using the T connectors. The last option is to use the internal boost converter, which converts the 5 volt from the USB into 24 volts, but this is only suitable if there's a low power draw from the 24 volt power rails. In step 3, you will specify the fluid you are using. You can give it a name and enter the calibration viscosity and temperature. After you're finished, you click on the Next Step button at the top to continue to the next page. In step 4, we will configure the test flow meter, which consists of its type, serial number, and also the port configuration, which means if it's 1 channel or 2 channel. And we will also need an approximate K-factor, which we can look up if it's a known VSE flow meter, or we can also measure by applying flow through both flow meters. In the measurement configuration step, you can set the number of cycles and the number of pulses to count, and you can change all the settings according to your specification. And there's also an advanced measurement configuration, which allows you to fine-tune the whole measurement. If you need more information about any of those options, you can always refer to the documentation. In step 6, you will set the calibration points that you want to measure. You can use the bottom buttons to manually add points, or you can use the template calculator to calculate some points in the range of the flow meter. This also allows you to use exponential curves so that more points are in the lower range of the flow meter where it's more unlinear. On the last page, you have to set your output directory where all of the calibration protocols will be stored, and will also set the protocol name, the name of the tester, and additional info you want to have on the calibration protocol. When you go to the next step, you will start the calibration procedure and you will be presented with this screen. Now you can turn on your pumps and adjust the flow rate according to the target flow rate. You can also refer to the live graphs on the right or use the numeric values on the left side. EasyCal will make sure that you are in the hysteresis window of the target flow rate and also will make sure that it stays there for a configurable amount of time. After the steadiness check is completed, the counting of the pulses will start and you will see the progress bars fill up. The duration of the point will depend on the number of pulses you set and the flow rate. Usually very low flow rates will take a long time to complete, and you might consider using a time limit for those long points to limit the number of pulses. But for a constant and high measurement accuracy, it's advisable to disable the time limit and always count the specified number of pulses. You now have to repeat the process until all of the calibration points and cycles have been completed. The number of remaining points and cycles will be shown on the right. After finishing the last calibration point, you can click on the Fill Calibration Protocol button, or you can go onto the Reports tab to create the calibration protocol. Use the result selector on the top left corner to select your protocol, edit the company data, and maybe add a logo and address. At the top you can find additional settings to change the appearance of the arrow diagram and also change the calculation method of the repeatability. Use the buttons at the top to export your data into an Excel sheet or export the protocol into PDF. All of your results are saved into the output directory you specified earlier, and you can always re-import the measurement to create a new calibration protocol.